Hi, this is Brian Noyes, and welcome to my course, Securing Angular Apps with OpenID Connect and OAuth 2. I'm a software architect with over 20 years experience, and have been working with Angular and other single-page application frameworks for over 5 years. I've seen many approaches to security, some good and some really bad. It's never been more important to make sure the apps you build and the data they manage are secure than it is today. There's also a growing expectation from users that apps will participate in a single sign-on experience for the user, so they don't have to remember and use separate accounts for every app they work with. In this course, I'll show you how you can use OpenID Connect and OAuth 2 protocols to secure your Angular apps with the most modern, interoperable, standardized, and secure protocols, and ones that allow your app to be part of a single sign-on ecosystem of apps for your users. You'll see how to handle the authentication process, getting your users logged in, and authorization or access control to make sure users can only see and do what they're supposed to within your app and the backend APIs that your app talks to. I'm really looking forward to showing you how easy it can be to do the right thing with security in your Angular apps. Hi, this is Brian Noyes, and welcome to my Pluralsight course, Securing Angular Apps with OpenID Connect and OAuth 2. OpenID Connect and OAuth 2 are the most modern and standardized approaches for authenticating users and authorizing their access to your apps and data. These protocols also let users of your app participate in a single sign-on experience across one or more applications in a federated ecosystem of applications. Implementing your security with these protocols helps guide you to follow best practices on security, and available libraries and platform support for the protocols limit how much you need to know about the inner workings of the protocol to implement them correctly. So let's talk about what you're going to learn in this course. In this course, you'll learn how to handle everything on the client side in your Angular app related to authentication and authorization. You'll first learn the high-level security concepts you need to know about security in general and the OpenID Connect and OAuth 2 protocols. Then you'll learn about the concepts behind OpenID Connect authentication, including how to get your users logged in with your identity provider to obtain the identity and access tokens you'll need for the rest of your security flows. In this module, I'll also make sure you know how to get the sample code all running on your machine. Next, I'll walk through the implementation of getting OpenID Connect authentication all coded up in your Angular apps. I'll first show you how to do everything using Identity Server as your STS. After that, I will show how things change if you switch to a cloud-based identity provider, which I'll show by switching the client application to use auth 0 as an identity provider instead of Identity Server. Next, you'll learn how to pass tokens to your backend APIs to authenticate and authorize your calls, and use the claims sent in the access token to filter data in your APIs, as well as make access control decisions in the code of the API. After that, I'll wrap up by showing how you keep your login session alive by using a silent renew pattern for your access tokens. Then I'll cover how to use the security context of the user and their login with the identity provider to manage the user experience, to do things like control what pages in the app they can see, and hiding and showing parts of the UI based on permissions. So let's dive right in. This course is designed for a developer who has already been exposed to the fundamentals of building applications with Angular. Some exposure to the Angular CLI, Angular data binding, routing, and dependency injection will be required to fully follow along with the demos in this course. Additionally, since I'll be showing some backend code for APIs and for Identity Server 4 as an STS in this course, some exposure to ASP.NET Core would be good as well. You can find a number of courses to get you up to speed on the fundamentals of Angular and ASP.NET Core in the Pluralsight library. In this first module, I'm going to make sure you're familiar with the overall security landscape for Angular apps. I'll cover the high-level concepts you really need to know when focusing on the security of your application. You'll learn about the OpenID Connect and OAuth 2 protocols at a high level so you can understand what's going on behind the scenes without knowing all the gory details or needing to implement those details yourself. You'll also learn about some of the identity providers that exist that you can use with these protocols and what client libraries are available to help you implement them in your apps. There are a number of security considerations that you should make sure are covered in your application design and architecture. The first two are authentication and authorization, which will be the primary focus of this course. Other things you should make sure are part of your design include transport protection, cross-origin resource sharing, or CORS, cross-site request forgery, or CSRF, and cross-site scripting, typically abbreviated XSS, so it doesn't get confused with CSS styling. I'll be going into a lot more depth on authentication and authorization throughout the course, but let's talk briefly about the latter four. Transport protection refers to how you protect the requests and responses that are made between the browser and backend resources that your application talks to. This also applies to any backend to backend communications between services. This one is pretty simple. Just use HTTPS everywhere. The underlying HTTPS protocol is often referred to as SSL for Secure Sockets Layer, which is actually a somewhat outdated term. The protocols used in modern-day HTTPS are more correctly referred to as TLS for Transport Layer Security, a newer version of the SSL security protocol. Despite that, the term SSL is still commonly used when describing the certificates that you use to implement TLS. The bottom line is that you should be using HTTPS for any calls in your application that could contain sensitive information. And the only way to really protect yourself there is to just use it for everything, because you don't know how the data flows of your application are going to evolve over time. So most apps simply protect the entire site and all API calls with HTTPS, and that's generally the right thing to do. You don't have to do anything explicit in your client-side Angular code for this, other than making sure the URLs you are using to call your backend APIs are prefixed with HTTPS instead of just HTTP. The next security consideration is cross-origin resource sharing, or CORS for short. Since the early days of the web, browsers have restricted client-side code from being able to make HTTP requests to any site other than the site that the client code came from. There are specific security threats this mechanism was designed for, but as applications evolved from just being static content rendered by the server side to more and more sophisticated interactive applications on the client side, this became a limitation that had to be worked around. Modern browsers have standardized on the CORS protocol for how to explicitly manage what sites your code can call out to. I'll cover CORS briefly in the module on authorization. Again, you don't have to do anything explicit in your Angular code because the Angular HTTP client service will take care of sending and receiving the right headers for you based on the CORS protocol. The next security consideration is cross-site request forgery, or CSRF for short. CSRF is a vulnerability that exists when using cookies to maintain a secure session with a backend web server. If you've ever used the mechanism typically referred to as forms authentication, then you have used cookies to maintain secure sessions. The vulnerability exists because of the fact that the browser will automatically send any cookies associated with a given site anytime a request is made to that site, even if the request originates from a separate browser tab or window than the one that originally connected and got the cookies back in a response. So let's say you log into your bank in one browser tab and it returns a cookie for your authorized session. Then you go to another site in a different tab. If that site's page code sends a request to your bank site, the cookie that authorizes your calls from the original tab to the bank will be sent along with the request from the other tab. potentially authorizing that site's code to do privileged operations that were never intended to be exposed to the other site's code, such as transferring money from your account. The good news is that using token-based protocols, including OpenID Connect and OAuth 2, makes it so you don't have to worry about CSRF, because these protocols require your client-side code to explicitly put the tokens into authorization headers of any HTTP request to your APIs. So there is nothing automatic that is going to cause those tokens to be sent. Code running in other tabs in the browser will never have access to those tokens, nor be able to send them in a request to your APIs. The last consideration is cross-site scripting, or XSS for short. The cross-site scripting vulnerability occurs when you take direct input from a user, say a string in a text box, and then inject that directly into the DOM. If that input contains certain expressions, such as a script block, it can be executed as soon as it's inserted into the DOM, or it can set up event handlers that execute later. This could allow a user to execute scripts that cause your app to do things they were never intended to do. The good news is Angular has your back here. Angular treats values that are put into the DOM through data binding as untrusted, and will sanitize or escape parts of the values that contain something like a script block that could be executed. You still have to make sure that the end user input doesn't ever get turned into executable code directly, but that would be a dangerous thing to do in most cases anyway. So for the most part, you don't have to do anything explicit to be protected from cross-site scripting in your Angular apps. For more in-depth coverage of these security considerations, I suggest you check out the Pluralsight course, AngularJS Security Fundamentals by Troy Hunt. Even though it uses AngularJS, meaning version 1.x, the coverage of these vulnerabilities there is still completely relevant to Angular 2 and later applications. One very important concept to make sure you always remember: you can't really secure any code that runs in the browser. Anyone with any knowledge of web development can simply open the developer tools in the browser, access the code, and make whatever changes they want. For production code, you should be minifying or uglifying your code, which does make a hacker's job harder. But that's done more for shrinking the size of the code files the browser needs to download than it is to make your code hard to hack. But that is a good side effect of doing so. So if you think you will secure your app by doing things like filtering what data the user sees on the client side, or restricting what pages they can get to through Angular routing, or disallowing certain actions based on who the user is, you need to realize that it won't. You should still use features like Angular route guards to tailor the user experience and prevent the user from getting to pages they should not be able to use. You can also use data binding to security context data to hide or disable actions that the user should not use. But just realize that's not really securing anything. You're just setting up a better user experience. All of your true security protections need to happen on the server side. There you can filter data so it never gets to the client side if the user should not have access to it. You can also refuse requests to API endpoints that the current user is not authorized for. So even if, let's say, a hacker goes and enables a button to delete a customer's order history that they're not supposed to be able to do, when the request gets to the server side, it should fail. Another thing to understand about OpenID Connect and OAuth 2 is how it affects the architecture of your Angular app and the backend for that app. Most web applications are designed to handle both authentication and authorization internally within the host application site. So your host site would render out the root page for your Angular app, and the user would have to log in either prior to getting to that page or from inside the Angular app itself. And then once the user is logged in, you could secure the calls that come back down to the APIs of your app based on either cookies or some other form of security token that would work only with that site. The host for your Angular app and the APIs could be in separate sites, and if so, you typically would not need a user to log in just to render the Angular app, because the structure of your pages is rarely what you want to protect. But then as soon as the Angular app started accessing any sensitive data, you would want to have the user log in and then start calling the authenticated and access control protected APIs. Once you start using OpenID Connect, you will typically have a separate site for your identity provider. It's possible to integrate it into a single site along with your pages and APIs, but you should generally avoid doing so. Part of the benefit of using OpenID Connect and auth 2 is that you can separate the concerns of authentication and high-level access control into the identity provider. Then your app doesn't have to worry about collecting credentials from the user and validating them. It just needs an access token from the identity provider that tells it this is an authorized user for your app. And separating out these responsibilities like this opens the door for enabling single sign-on across a collection of applications that all use the same identity provider. Now let me briefly cover the difference between authentication and authorization, just to make sure you're clear on the difference. Authentication is focused entirely on determining the identity of the user or client application. Keep in mind these security protocols don't just apply to end users logging into your client applications. They also apply to calls from one backend system or service to another. The first part of authentication is requiring the user or client to present their credentials. This can be triggered by redirecting the user to a login screen, or it could be triggered by a 401 status code returned from an API call indicating that authentication is required. Then the user or client application needs to present an acceptable form of credentials. For an end user, this could be a username and password, a biometric device scan, or presentation of a client certificate with something like a smart card. For a client application that is not being controlled by an end user, this is typically going to be a shared secret. In simplest form, this is just an arbitrary and hopefully unique enough string of characters that it's difficult to guess. Usually the shared secret you'll use will be based on a cryptographic hashing algorithm that makes it both unique enough and hard to guess. The identity provider will need to be able to verify the credentials, and then it will issue a temporary, meaning time-limited, credential that can be used to authenticate and be allowed access to your application or APIs. Anyone who's been in the military or larger business buildings has probably experienced something very similar outside the realm of computers. You want to gain access to some facility, but first you must go to a guard station at the periphery of the facility. You present a set of credentials, such as your driver's license, passport, or company ID. Then the guard issues you a badge that you must wear while in the facility, and maybe use that badge to gain access to specific buildings, rooms, or floors within the facility through an electronic badge scanner. This is essentially what you're doing during OpenID Connect authentication. The guard station is the identity provider, and the initial set of credentials is typically your username and password. Then the issued ID and access tokens from the identity provider are the temporary credential for a limited time session of access to the requested resource. Authorization has to follow authentication because it relies on knowing the identity of the user or client application that's trying to gain access to a resource. Authorization might include looking up the roles the user is associated with and using the membership in those roles to authorize access to operations or data. It could also be based on more fine-grained permissions that are application-specific, such as which user can edit which entity. In this case, the identity provider should not be the one managing those permissions because they are application-specific. But we'll get into that more in the authorization module. Authorization could also be based on a security policy that takes into consideration both roles and fine-grained permissions. Ultimately, the authorization code in the resources being accessed needs to validate user actions or data access against what they should be allowed to do. There's a fair bit of terminology surrounding the OpenID Connect and OAuth 2 protocols you should be aware of. First, there is the identity provider. As shown in the architecture diagrams earlier in the module, this is almost always a separate site from the application a user is interacting with. There are a bunch of other names, sometimes used for an identity provider. These include authentication server, authorization server, single sign-on server, and STS for security token service. Using the term identity provider or STS are the most accurate terms because authentication, authorization, and single sign-on are all aspects of what the identity provider does, but not the whole picture. Next, there is the user agent. I think you know what a user is, but a user agent is basically the piece of software the user is directly interacting with. This might be your client application in the browser, or even the operating system if using built-in mechanisms for native apps to collect credentials outside of your app. Next, there is the client. Again, this represents a piece of software, not the user, and in a lot of cases, it is the application that the user is interacting with. But just remember, it could also be a backend API or batch process running with no interactive user. Ultimately, it is the software that is trying to access a resource outside of its own scope of control, so the client needs to authenticate and be authorized by that resource's identity provider. Next, there is the resource. This is the thing that a user or client is trying to access. This could be the website itself, or in the context of an Angular app, the resources are typically the APIs that your app calls out to through HTTP. But outside the context of Angular, it could be a website, database, or file store that a user or client app needs to access. Scope is another term you'll want to be familiar with. Scopes are part of the configuration of an identity provider and represent the individual resources that that identity provider protects. When a client connects to the identity provider to authenticate, it tells the identity provider what scopes it is requesting. Then the identity provider checks the configuration for that client to see if it's intended to access the associated resource. And an end user will experience scopes when using external identity providers like Google or Facebook in the form of consent screens that confirm with the user that they want to allow the application access to the resources requested. The last term you'll hear me use a number of times in the course is JWT. This is how people in security disciplines refer to JSON Web Tokens. JSON Web Tokens are the format used to encode information about the authenticated user in an identity token and claims about what they can access in the form of scopes in access tokens. These are a standard format used for both OpenID Connect and OAuth 2 protocols. So now let me focus on the high-level details of the two protocols this course centers on. First, let's talk about OAuth 2, since it came out before OpenID Connect. The first version of OAuth started around 2006 and focused on delegating access control responsibility for APIs, specifically the Twitter APIs. OAuth 1 became an approved standard in 2010, but the spec for OAuth 2 was already underway. OAuth 2 broadened the focus for the protocol to include websites, mobile apps, desktop apps, and APIs. OAuth 2 became an approved standard in 2012. The only problem with OAuth is that it's actually a protocol for authorization only. There was no standard for how you authenticate someone first, so that you could then make the decisions about what to allow them to do. So it was up to the individual identity providers to do their own thing. So that led to needing a standard for how the authentication process happens, which became OpenID Connect. OpenID Connect is a derivative standard from OAuth 2. OAuth 2 had already standardized on a token format, JWT, that OpenID Connect could use as well. OpenID Connect presumes you will be using OAuth for the authorization piece, So part of the authentication process is to obtain not only an identity token representing the identity of the end user or client application, but also an access token that specifies what the holder of that token can do with respect to the resources it's requesting access to. OpenID Connect was approved as a standard in 2014 and has been gaining widespread adoption ever since. This protocol includes specifying the flow for how a user gets redirected to a login page at the identity provider, or how credentials are sent directly in the case of non-end user clients, as well as how control gets returned to the application and the tokens that are issued. You'll learn more about OpenID Connect in the next module, and OAuth 2 in the module that follows that, including the important part, how to use them in your Angular apps. But before we get there, let me quickly cover the options you have for identity providers and client libraries to help you implement all this stuff. There are a lot of choices for identity providers out there, and which you choose will depend largely on who your target audience is. The first set of choices that most developers will already be familiar with are Google, Facebook, Twitter, and other social media providers. If your app will be a consumer-facing app, and you want them to be able to sign in with identities they already have with those social media platforms, then you can use one or several of those as your identity provider. You've probably seen this before with web or mobile apps you use. When you first go to register, you might have the option to select one of these identity providers to sign in with. However, most apps don't want to force you to go establish an identity with one of those identity providers if you don't already have one. Also, many users don't want to use one of their social identities for application access for fear that the application may try to access more of their social platform profile or capabilities than they want to. For example, posting to their Facebook or Twitter feed without them realizing it. I'll talk more about that in the module on authorization, but the bottom line is that it is usually insufficient to just rely on one of those providers. You'll usually want to support having user accounts that you can manage through an identity provider that you set up and control. Then you can support single sign-on from other identity providers using the OpenID Connect and OAuth 2 protocols. So if you're setting up your own identity provider, there are a number of security as a service providers that give you cloud or on-premise options for setting up and managing that provider. The first I'll mention is the hardest one to understand because it has several different variants, each with different sets of capabilities. The first of these variants is just named Azure Active Directory with no stated suffix, which usually means the first version of that service. Azure Active Directory is called AAD for short. The version 1 service does not support OpenID Connect and was more focused on establishing a cloud-based domain for your users and optionally federating that domain with on-premises Active Directory domains or other AAD domains. Azure Active Directory v2, which is a newer version of the AAD APIs, does support OpenID Connect, but only for Microsoft organizational accounts, which are also called work or school accounts, and Microsoft accounts, ones that you have registered with an email address that can be used for things like Office 365, Xbox, Microsoft Developer Networks, or other cloud-based Microsoft services. And finally, the third variant is Azure Active Directory Business to Consumer, or B2C for short, which allows you to use any Microsoft account, as well as external social identity providers, and even users that you just registered directly with your AAD B2C accounts using their email. All of these variants are pay-as-you-go cloud services. Then there are a number of identity as a service providers. These include Auth0, Okta, Ping Identity, and many others. One of the value propositions of these is that they provide a fully managed service that is compliant with the standard protocols, so there's no setup, hosting, patching, or management of those services at a low level. All you have to do is set up an account or tenant with them, do some configuration through their user interface or expose management APIs, and you're ready to go. But of course, these all have a recurring subscription cost that are typically based on the number of users you have and or how many security transactions, such as login and log out, your application has. The last one I want to mention, and we'll be using for the samples in this course, is Identity Server 4. Identity Server is an open source framework for building your own protocol-compliant identity provider. It is open source, so free to adopt, but being a framework and not a pay-as-you-go service like the other options, you have to do some development to get it set up and ready to go. And you will have to host your identity provider somewhere yourself. This could be in the cloud through something like Azure Web Apps or a cloud virtual machine, or you could host it on-premise in your own web servers. Identity Server has the most flexibility in terms of integrating with other identity providers and supports integrating with external providers for single sign-on, including Active Directory Federation services for on-premise or cloud hybrid deployments, Azure Active Directory, or any other OpenID Connect and OAuth 2 protocol-compliant identity provider. Identity Server 4 is certified by the OpenID Foundation as being protocol compliant. You can see what other providers are compliant on the page shown below. Now that you have a sense of the options for standing up an identity provider for your app, let me talk briefly about the options you have for JavaScript client libraries that help you implement the OpenID Connect and OAuth 2 protocols in your Angular applications. Because these are open standard protocols, there are a number of client libraries out there that you can use. The first and most minimal library is Angular-JWT. This library does nothing more than help you get your access tokens that have been issued by an identity provider attached to your outgoing API requests. It leaves it up to you to manage redirecting to your identity provider and collecting the return tokens on your own. The next client library you might come across is the Microsoft Azure Active Directory Authentication Library, or ADAL for short. This library is for Azure Active Directory and is not compliant with OpenID Connect. Additionally, it has been superseded by the Microsoft Authentication Library, or MSAL. This library does use the OpenID Connect and OAuth 2 protocols, but has some specifics to Microsoft Azure Active Directory in it. If Azure Active Directory is going to be your STS, you should probably just use this library. But if you're going to use a different platform or provider for your STS, you will likely run into problems trying to use the MSAL library with other OpenID Connect and OAuth 2 services. The one I recommend and will be using for this course is the OIDC-Client library. This is implemented by the same team that implements Identity Server, but it is designed not to be coupled to Identity Server at all. Instead, it is a fully protocol-compliant implementation of the client flows for OpenID Connect and OAuth 2. It is also certified by the OpenID Foundation as being fully compliant with the protocol. Before we wrap up this module, let me give you a quick tour of the application we'll be working with for the rest of this course. What I'm showing is the completed version of the app with all authentication and authorization in place. First, as you can see, the scenario is a simple project management app. Note that this site is running on port 4200 on localhost. You can see that the first thing you'll want to do is log into the app. The demo app includes several built-in accounts I'll cover later. If I start by clicking on Login, we get started into the OpenID Connect flow, which I'll talk about more in the next module. You can see we're redirected to the identity provider and asked to log in there. I'll log in with the user alice@globalmantics.com. The password for all sample accounts is test with a capital T, 123, and then 3 exclamation marks. Once I enter my credentials and log in, we get redirected back to our application. Now you can see the menu bar has updated with actions to go to our projects or log out. If I log out with that account, I actually get quickly redirected back to the identity provider,